Hello everyone and welcome to our presentation today. My name is Paul Arsov and I'm the founder of the Decentralized Web project. The topic of our educational presentation today is understanding human mind, not a trivial or easy task. The formulation of detailed and rigorous theory of what artificial general intelligence is a small but significant part of the AGI community ongoing research. It has been discussed in many ways and about how difficult it has been to define the core human task. That is what the human mind does. There are many reasons for the attainment of this definition, why it is so elusive. An awareness of the obstacles that prevent progress or misdirect research may provide clues as to how to overcome these hurdles. In this presentation, we will list those hidden ideological and practical impediments to self-understanding, dividing them in two broad categories. The first category is focused on the human factors. That is how researchers' own attitudes and motives can stand in the way of their understanding. And the second group deals with pragmatic difficulties in development of comprehensive theory of mind. So let's go with part one. And this presentation actually deals only with part one, and next week we're going with part two. The single greatest impediment to progress towards full theory of mind is also the most rarely recognized. Understanding the mind is like understanding any topic, for example, finance or literature. We may approach the topic with the right attitude, being receptive to the concepts involved. If there is any aspect of our beliefs about the mind that we're unwilling to question or challenge, our own dogma will likely stand in the way of arriving at a complete comprehensive theory. But here are a few of the reasons wayward investigator may accidentally close doors to their own education. The first one is excessive moralizing. With a topic as socially sensitive as the nature of the human mind, there is a tendency to moralize, to designate good versus bad thinking, right versus wrong judgments. When we theorize about the mind, we can't help but be aware of the social and political setting in which our theories will be discussed. Any ideological pressure exerted by our peers will influence what we publicly say and even privately think about the topic, making us subconsciously reticent to follow unpopular threads of argumentation. If it turned out, for example, that the mind were inherently irrational or even immoral, such a premise would be difficult to promote to others. And so it has been that historical theories which hint at distasteful implications, like, for example, that human existence is a meaningless struggle in a dog-eat-dog world, or that morality is an expression of weakness, or that psychosexual repression drives intelligent evolution, as Freud is saying. Um, all of these theories had difficulty attracting a wide audience, being rejected by those who find the possibility either uncomfortable or socially deleterious. Whether or not the theories contains a nugget of truth, those avenues were largely shattered in favor of more sensible, or shall we say, tasteful opinions. Equally, any attempt to promote a positive, pro-social, or optimistic perspective of psychology can be just as inhibiting on scientific progress. Um, Foucault, in Madness of Civilization, describes how moral imperatives permeated every aspect of the definition of insanity, the phenomenon being described at various times as a morally failing, an archetypal symbol of human frailty, or a cause for pity, charity, and empathy. Each of these mindsets frames aberrant psychology in its own moral light, and aligns with them with contemporary prerogative for um, inculcating social cohesion. Indeed, treating failures of the mind, such as psychiatric disorders, still remains one of the strongest motivation to understand how the brain works. And so the above ideological influences have not disappeared. And though useful in its own respect, the pursuit may bias new discoveries by skewing them towards concepts and categories framed around helping the afflicted. Researchers inevitably evaluate a mind as healthy or unhealthy, competent or incompetent, and in doing so inject an observer's moralizing judgment. At last, more subtle form of moralizing is an evaluation of relative intelligence. This is frequently a driving force in the field of cognitive science, rooted in a researcher's judgment of what counts as intelligent. An experiment still situates its test subject on a continuum according to what it implicitly asserts as valuable, gauging them as more or less rational, competent, or reasonable according to how well they perform on tests of logic and reasoning. This projects the expectations of the researcher onto the evaluation of the subject. On a similar note, scientific judgments of artistic merit regularly misunderstood or misconstrued the nature of artistic expression as identical with popularity or sales, relegating art into an industrial consumer process. The second one in this first group is uncomfortable truths. The truths about the mind, whether they may prove to be, will govern all aspects of human existence and happiness. The revelation may, in the process, expose uncomfortable truths that some people are not ready to confront. For example, to seriously consider any mechanical model of the psyche, you may first be comfortable with the notion of the mind as a deterministic machine. Without demanding, the theory reserves space for the free will. Not everyone is up to this challenge. There may be an unwillingness to accept that, say, human happiness cannot be maintained for any extended duration of time, or that all truths, even scientific ones, are relativistic, or that life and the world have no inherent meaning or purpose. To understand any theory requires a certain comfort in the latent connotations it carries. Discomfort with any of this will be an impediment to understanding what the mind is and how it works. Truth is not always empowering. Yet, one of the main reasons people seek to understand the mind is psychologically pragmatic, to give them strength and confidence in their self-understanding, to reinforce an image of themselves as unified, self-consistent, and self-reliant. For many people, to deny the self and insert in its place directionless automation amounts to a denial of everything important about their own existence, a kind of overture to nihilism. We should not be surprised when the mind resists such a conclusion. A common symptom of this underlying prejudice is expressed in dogmatic statements like I know that I'm conscious and that is beyond a doubt. Such assertions suggest an aversion thoroughly to thoroughly analyzing the brain or consciousness. A willingness to break down one's ego and precious sense of identity may be necessary for progress along the path to general AI. And the next impediment is lazy reductionism or abstraction. With a machine as complex as the brain, it is often easy to abstract away various aspects behind hand-waving explanations rather than dealing with concrete details. This tendency is more a pragmatic necessity than anything nefarious, since it reduces the burden of work to a subset that can be addressed, while abstracting the rest that remains out of reach. But the practice is not always benign. A pernicious example is the tendency to defer a given mental process to a murky evolutionary explanation, like we evolved this ability to do X, which hides any real explanations behind plausible sounding non-explanations. It redirects the conversation away from an analysis of systematic cognitive patterns towards naturalistic or ecological perspective, one that is ultimately unproductive when designing artificial intelligence. In the short term, reductionism may be unavoidable. Human minds are overwhelmingly complex, able to perform diverse functions across a variety of domains: art, science, philosophy, maths, socialization, athletics, spirituality, playing games, self-understanding, and etc. are only a few examples. To explain the mind is to explain how it performs all of this, and that requires at least passing familiarity with each of them, if not a deep empathy with the motives that drive each discipline. Few people are such polymaths as to claim to be familiar with all fields of human exploration. The temptation, therefore, is to simplify or dismiss anything a researcher doesn't understand as unimportant or unnecessary, since the alternative, to try to understand, may be too difficult uh, or it takes too long. AI researchers, for example, tend to be scientifically minded, and this shows in models of mind which idealize a rational, logical human image of human cognition. Art, spirituality, or poetry are consigned to the undifferentiated heap of irrational human artifacts. In the long run, however, to understand the mind is to understand all of it. Sticking in one field or perspective and downplaying others we can't relate to as erroneous or misguided will always remain an impediment to a development of full theory of mind. And another impediment is species pride and species denigration. As members of our own species, it is tempting to take pride in our intellectual superiority as rational creatures and reject any suggestion that we may not be as intelligent or objective as we think we are. Those with a rationalist bent want to believe that humans are more competent, thorough, and logical than actually we are. They may deny models that try to pull back on the full possibilities of logical AI as unnecessarily limiting the agent's capability. On the other hand, it's not also common to denigrate our species as irrational, animalistic, deeply flawed, immoral, predictable, and self-deluded. This is an equally unproductive perspective. It is occasionally rooted in resentment or um, misanthropy, um, though in most cases it's simply a desire to knock down our own extended ego to a more realistic levels. Either way, one can go too far in denigrating human intelligence. A recent tendency is for researchers of natural language models to reduce language production to a mere imitation of what others have said before, thus denying the ability for language and ultimately thinking to evolve with human needs. And another impediment is private motives. The desire to deeply explore and fully understand the mind is not everyone's cup of tea, and it is difficult to teach someone who has not interest in or is actively averse to psychology about its nuances. Those who engage in the pursuit are usually driven by private motives that are strong enough to push past the many disappointments that inevitably experience along the way. However, these motives often become their own roadblocks. The desire for a priority to be the first discoverer of artificial general intelligence, or the need to be recognized for one's contributions, or simply to help resolve one's own private psychological issues, may steer an individual away from certain more promising paths. Um, Overweening pride or arrogance, the need for public esteem, a fear of failure or embarrassment, and any number of public commitment fallacies are similarly detrimental to intellectual growth and cognitive progress. Character conflicts are rife in academia and may also impact one's ability to publicly admit one's own mistakes. Researchers are only human after all, and their thinking can be derailed by the impetus to defend their political or ideological opponents. Wherever their party allegiance, its members will tend to misunderstand or reject anything from their opponents' camps, even when a synthesis of ideas would prove more productive. Even simple clashes of personalities may impede the attainment of useful knowledge. For example, a visceral distaste for cold clinical researchers um, or airy-fairy, wishy-washy artists or idle armchair philosopher can preemptively close off avenues of useful investigation if the prejudicial feelings are strong enough. And with this said, we're ending part one of this presentation. Stay tuned for part two, which is going to discuss practical impediments to understanding of the human mind. And with this said, I will be coming back to the beginning of this presentation when I told you that my name is Paul Arsov I'm the founder of the Decentralized Web project, and we're working on several projects that I like to tell you about. The first project that we work on is a marketplace and collection of non-fungible tokens, or abbreviated as NFTs. What is interesting, special, or unique about this project is that our own NFTs are based on three-dimensional objects. With three-dimensional objects, there has to be some special software which loads and displays the three-dimensional object, and most often creators of 3D objects, they use game engines software. Currently, there are two popular choices of game engines used by 3D object creators. The first one is called Unity, and the other one is called Unreal. But from the very beginning in our project, we decided to build our own 3D software engine, and what it does, it reads the file of the 3D object, then it opens a window on a computer screen. It loads and displays the 3D object in this window, and it starts animating the 3D object in a way of moving it in a random fashion around the window. But in addition to reading the file, opening a window, loading and animating the 3D object, our 3D software engine has multiple additional capabilities. The first additional capability is the capability of speaking. Our 3D NFTs can speak in one of three basic voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed manner or in a fast speed manner or in a slow speed manner. So if we take a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a masculine person or the voice of an old person. If on the other hand we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a funny person or the voice of a little girl. The next additional and important capability for our 3D NFTs is the capability of voice recognition. The 3D NFTs can speak, can recognize voice commands, and if we have, for example, a 3D NFT which is moving in a random fashion, being animated, then we can issue our very first voice command to the 3D NFT to stop moving, and then the 3D NFT is going to stand still and stop moving. We can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. The next additional and important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply in few sentences on who they are. You can ask the 3D NFT to describe something, like for example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or about decentralization or about the country called Russia. The last additional but not least important capability is the capability of the 3D NFTs being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can you can come to our 3D NFT marketplace, and probably now is the time to tell you the name and the URL of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is all together 3D NFT. Then there is dot, then there are two words, decentralized and web, and they are typed all together, decentralized web. Then there is dot and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page and every other page, you are going to see number of links, and one of these links is going to point to accessories. You can click on this link and you're going to see that we're offering special glasses. You can click and order one pair of these glasses, and when you receive these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue. Then you can put these glasses on. You can request displaying the 3D NFT in a way of stereoscopics, and then you are going to see the 3D NFT is coming out of the flat two-dimensional computer screen, and you're going to see the 3D NFT in real 3 dimensions. With this said, I am going to end talking about our 3D NFTs and 3D software engine, and I like to tell you a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance. It runs Ethereum software, and it is the same software which runs on Ethereum mainnet. It runs Binance Smart Chain, it runs Polygon Matic chain, it runs Avalanche Avax blockchain, and it runs many other blockchains currently in existence. By running our own blockchain instance, we do not require our users to pay gas fees for the deployments of the smart contracts for the non-fungible tokens, and they do not pay gas fees for the transactions of transfer of ownership from one user to another user. By having our own blockchain instance, also we allow our users to pay for the purchase of the non-fungible tokens in multiple crypto coins and receive proceedings from sale in multiple crypto coins. Currently, we have 4 different choices of crypto coins for buying and selling, and the choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and receiving proceedings from sale in crypto coins, we have a second parallel and independent way of buying and selling 3D NFTs, and it is done entirely with fiat currency. I can give an example. For example, if you are a user, you come to our 3D NFT marketplace, you load the main page of the 3D NFT marketplace, you can click on the image, composite image of our first collection, and then you are going to see all of the 3D NFTs in our first collection listed one after another. Then you can browse through these 3D NFTs in our first collection, and when you see one 3D NFT that you like, you can click on it. Then you're going to see a short video of this 3D NFT as it is moving, and then you are going to see a drop-down menu which is asking to select a way of payment between 4 different crypto coins and a 5th choice of paying with fiat currency. So let's say you select paying with fiat currency, you click on the button to advance next. You're going to be asked to put the number of your debit or credit card, expiration date, CVC, and when you click to complete this transaction, what is going to happen is there's going to be a conversion from your national fiat currency, which could be different than US dollar, and this payment is going to be converted to US dollars and deposited in our bank account. We're going to follow this action with the second action and transfer of the initial ownership from our 3D NFT marketplace to you, and you become currently owner of this 3D NFT. You can play for a while with this 3D NFT, and then at some point you can decide to put this 3D NFT for sale. You decide on the price that you want to put for sale for this 3D NFT, and let's say there's a second user who comes to our 3D NFT marketplace. They browse through the collection of 3D NFTs, and let's say they like particularly the 3D NFT that you put for sale. What this second user could do is the same thing of clicking on this 3D NFT, then going through the drop-down menu of selecting of payment with crypto or payment with fiat currency. So let's say the second user selects payment with fiat currency. They click on the button to advance next, and they put the number of their debit or credit card, and they complete the transaction. What is going to happen then is there's going to be a conversion from the national fiat currency of the second user, which could be different than your national fiat currency and different than US dollar. And this transaction is going to be converted to US dollars and deposited in our bank account. We're going to follow this first action with the second action and transaction of transfer of ownership from you, the first user, to the second user, and now the second user becomes owner of this 3D NFT. We are going to follow this second action with the third action and transfer and conversion from US dollars to your national fiat currency, and deposit of this transfer in your national fiat currency in your bank account of the payment for the sale of the 3D NFT. With this said, I'm ending talking about this first project. I like to tell you about another project that we're working on, and this project is related with electric vehicles. And currently, electric vehicles are experiencing increasing growth in numbers, and the way of handling the charging of these electric vehicles resembles the model used for internal combustion engines and their loading of fuel. Internal combustion engines, they go to gas stations, they come to a specific gas column, they put the hose in their opening of their gas tank, they start loading gas in their vehicle, then they make payment for the gas loaded, and they leave the gas station. In a similar way, currently the charging of electric vehicles is handled by electric vehicles coming to special locations where there are limited number of columns, and the electric vehicle comes and stops at one of these columns. They connect the cable of this charging station column to their vehicle. They start loading electric energy in their vehicle. Then they pay for loaded energy in their electric vehicle, and they can actually stay for a while their vehicle is charging, and this timing is counted in maybe several minutes or tens of minutes or even an hour or more. And then after charging, electric vehicle is leaving this location, which resembles a charging station or a gas station for resembling gas station for internal combustion engines. But we anticipate and we estimate that a number of these charging stations is ultimately going to become insufficient for handling the exponentially growing number of electric vehicles. And in our project, what we are proposing, and we actually wrote an article about this, comparing gas station model versus parking lot model. In this article, we anticipate that there's going to be a transition towards charging electric vehicles at the point of the parking lot, and currently homeowners can do this in their own home, but many people people are living, especially in the cities, are living in high-rise buildings, and these buildings have multiple floors and like either ground level parking lot or underground multiple levels of parking lot if we have high-rise building with multiple floors. So what we anticipate is the transition to people, to owners of electric vehicles which come to the parking lot at the place they're living, and they leave their vehicle for the evening, for the night and early morning, and during this time the vehicle can charge in charging station mounted in the parking lot location. So we're basing our assumption and we're building products handling this parking lot at the place of living. But in addition to the place of living, many people of active working age, they work in office buildings which are also high-rise buildings. They have either ground level parking lot or multiple levels of underground parking lots. In these office buildings, there could be the same multiple vehicle handling parking lot chargers. So a vehicle which the user coming to work is living in the parking lot can charge during the morning, afternoon, and maybe early evening while the person is working in the office. So what we're building for this situation that we're anticipating is charging station which can handle multiple vehicles, and it is going to be mounted in the parking lot place, and it is in this charging station there is going to be a near field reader which can read the debit card or credit card or near field communication token, which could be a card, it could be a token which is mounted in a key ring, or it can be even a ring which the user can wear, and they can identify themselves to the charger. Then they're going to connect specific cable, one of multiple cables, to their vehicle, and they can initiate charging of their vehicle. With this said, by working with this specific product, by making this specific product, we also have this product being remotely controlled and remotely handled. So in this way, we can help also electric utility providers, and we anticipate the case for the electric utility provider where they have to handle sudden load of electric, sudden demand and load for request for load for electric power, and so we know that like electric utility providers have to have a balance between supply and demand. If there is very little imbalance between supply and demand, it is going to trigger like maybe blackouts and loss of electric power for specific locations, entire neighborhood, or entire cities. To alleviate this problem, we can provide to the electric utility providers a request for charging with a specific amount of power which is requested for chargers. We can aggregate number of electric chargers which are remotely connected with the sum of power which is demanded to a specific office building or specific multiple groups of buildings, whether they're office or residential high-rise buildings. And the electric utility provider then can bring the necessary generating capability to handle this demand, and we can then start gradually connecting electric power to the specific one or more vehicles at a specific building, be it office or residential building. With this said, I like to tell you the name and the URL of this project that we're working on and the products that we're building. The name and the URL is power.arstec.com. Power is the ordinary word for power, then there's dot, then there's something sounding like Arstec, which I can abbreviate with Alpha Romeo Sierra Tom Echo Charlie Hotel, and all together it's Arstec, then there's dot, and it ends with com. With this said, I'm ending talking about this second project that we're working on, and I like to tell you about the third project that we're working on. This project is called Elements of Artificial General Intelligence, where we can combine elements like voice synthesis, voice recognition, image detection, image classification, image recognition, and etc. With this project, we are going to be building software which combines these multiple elements in a way which is different than current what is labeled as artificial intelligence does. The current AI offerings, they're based on centralized intelligence, which relies on a very large processing capability, most often centered in one or more data centers. And this processing capability is then distributed to users, to multiple users, where a user requests something, like for example they have specific sentence or question which is sent to a centralized location, and then the answer is coming back to user as a result of processing capabilities centered in a specific location. But with our project, we are actually building this software to be individualized, to be centered with a specific computing power which is a modest, like a single or multi-core processor, whether with an accelerator or not. And this processing power is going to be having individualized uh, intelligence and maybe individualized consciousness. So it is going to interact with other individualized consciousness, and but it is going to be having their own speaking, voice recognition, vision, and etc. We do not have yet a website, but we're going to post our gathering of software on GitHub, and then build a website around this, and post articles about these projects as well. With this said, I'm ending this presentation. Thank you for coming. Thank you for viewing. Stay tuned for part 2 of this presentation for understanding the human mind. Take care. Have a nice day. Have a nice evening, and goodbye.